Hey, today I'm doing a walkthrough through AQA paper 3, 2017 paper. So this one, I've got the solutions on the link below, and you'll be able to see that in a bit more detail in this video. Right, value judgments are opinions, they're beliefs, they're what a person considers important. So it's something that's subjective, that changes depending on the person. And it's also something that science can't really answer very effectively because opinions vary person to person. So in terms of moral and political considerations, that's precisely what we need. We do need the science to help guide our decision making, but ultimately, because we need to make decisions on how we should spend money and what is best for the economy, that's inherently a value judgment. So we can't really kind of separate that. We need both the value judgments to tell us kind of what to do, to where we can use our values or opinions in the country, and combine that with the positive statements telling us kind of the facts. Okay, loft insulation, there's a shift of demand to the right. And here there's a whole bunch of things that are not demand related. So a decrease in VAT, did you know that's going to shift the supply curve? So it's not that one. A subsidy, again, that's going to shift your supply curve. So A and D are wrong. A maximum price, it actually makes just the price change. It doesn't actually shift anything, either the demand or the supply. So that's wrong. We need a shift in demand. And we're left with B being the answer. B is a nudge. You're making it a lot easier for people to be willing and able to demand loft insulation. So because they're more willing and able, that's going to shift that demand curve. Here, this was a tricky one. They have a lot of interesting definitions here. I'm going to guide you through which one that is diminishing return. So as more product is consumed, extra satisfaction will decline. That is the definition of diminishing marginal utility. This one sounds like a marginal product. And this one sounds like, oh, D is wrong. D is wrong. The total utility is maximized when marginal utility is 0. They're being a bit tricky with that one. We have the market for bricklayers, and we're considering what could raise the wage and the employment. So if we want to do both of these, we need an equilibrium here. And a shift of the supply curve won't clearly get to that. So we're looking for actually a shift of the demand curve to the right for bricklayers, going from D1 to D2. So I'm going to eliminate kind of anything that might be supply related or anything else. So cutting the bank rate, leading to a fall in mortgage interest rates. This is going to increase the demand for housing. And so you're going to need more bricklayers. That's going to increase the demand for bricklayers. Fall in the young people training, that shifts supply. An improvement in working conditions, that again increases your willingness to work in that industry, that supply. And increase in wages in another industry, that's going to mean people who are trained as a bricklayer are now going to train potentially to be an electrician. So that would be, again, supply. To work out constant returns to scale, we need to work out by what percentage output is increasing. That's not 50, that's 100. 100% is the percentage increase in output. And then you need to work out what the percentage in your inputs are. I need my calculator. Here we go. So add up all the inputs. So here we have 120 inputs. And the next row, add that up to, you get 80 plus 160 plus 240. 480, work out the percentage change between that, and you get 300%. So here we have decreasing return to scale because you've tripled your inputs and you've got less than that increase back in your output. So that's not constant, so we keep going. Here is another 100% increase in output. Let me just check what my new inputs are, adding up all the inputs. 420, 840, from 480 to 840. This is a, what is that? That's a 75% change. So here you've multiplied your inputs by 75%. You've got more than that back. This is increasing return to scale. We're not there yet, so we keep going. Output here changes by 50%. And your inputs have had to change from 840 to, it's a really long question, 1260. So work out by what percentage that has increased. So 1260 minus 840, and then divide all of that by 840 times by 100. That's increased by 50%. Here is our constant return to scale. We've got the same increase in inputs to outputs. So when it increases output from 2000 to 3000, the answer is C. Okay, this is a common question. Invention is something totally new. So we're not looking for any changes in something. It's something entirely new. This is that kind of thing I'm looking for. Again, improving something is not what we're looking for. Let me just double check. Innovation, tons of results of invention into product. Yeah, innovation is your incremental, your year-on-year improvement on an existing product. So the answer is C. Okay, to maximize profits, I'm guessing you guys have seen the MC equals MR condition, which is your usual way you do it, but here they're being sneaky and they don't give it to you. So the way you get around this, you could either write down your equation for profits, total revenue minus total cost. You could split this into its components, and then you can just realize to multiply these back, you can get your profit. So we will actually work this out. We'll work out add a column here where we work out the profits. So I'm going to do average revenue, and I'm going to minus average total cost, and then I'm going to multiply it by that. So I'm going to do 1 minus 2 in brackets times by column number 3. So 26 minus 15, put that in brackets, times that by 10, you get a profit of 110. Then you repeat 24 minus 14, times that by 11, so 110. 23 minus 13 times by 12, 120. And they make us check the last one. Whoops. That's 117. So you can see profits the highest at output 12. The answer is C. A monopoly, to be productively efficient, you're looking to produce where your costs are minimized. So that would be at output Y. So here the answer is C. That was a shorter one. Marginal revenue product. The equation for this is fun. It's MP times MR. And what this means is the addition to total revenue when the firm produces, this one. It's the revenue that your new employee gains. So that is what MRP means. If you want to calculate it, that's the equation. Here they have some other like similar sounding definitions. Don't get caught out by this. This sounds like MR. This amount produced per worker sounds like productivity. I'm going to call it prod. Change in total output. This sounds like MP. So be sure to learn your definitions and then you can get these super fast. So we need an increase in the demand for this. So we just need to work out how that happens. Right, did you know that the shift in the demand, I shouldn't really draw an arrow that way, I should kind of draw it this way. The shift in demand just does this. So when you start at E1, the increase in the demand means that the quantity demanded is now there. This is QD, because that's where your new supply curve is. Just so to be super clear, I'm going to actually kind of delete the old demand curve. It's not relevant anymore, it doesn't exist anymore. So that's gone. But your supply curve at P1 wants you to have QS here. So you've got a discrepancy right now at the same price. You've got more demand than supply, and this is called excess demand. So I'm looking for any of these options, and it's excess demand only at P1. This is what happens behind the scenes in a shift. A shift means there's more demand, less supply. The price doesn't change yet. It's only once there's been excess demand does that signal, does that incentivize, and that cause the rationing effect to get back to P2. And at P2, you have an equilibrium where your supply equals your demand. So the answer is A. The Genie coefficient, right, so to take the Genie coefficient, what you do, you have kind of a Lorentz curve here, and you take this area A, imagine you have, okay, so it's not a great one, you take your area A and divide it by A plus B. Area A is kind of like the bad one. It's the how far away you have become away from the line of equality. So this one's kind of bad. You're dividing it by all the possible area you could have had. So the higher that A is, the worse this is. So if A is really high, there's lots of inequality. You're going to get a really high Gini coefficient. And if you like a further explanation on this, that's in the link. So the highest Gini coefficient is D. D, in fact, I don't know how to draw D. It would look, all the entire area is consumed by the Lorentz curve. It's just there's A, there's no B. So that would be an economy where one person owns all the income in the economy. Right, tragedy of the commons, this is a difficult one. Tragedy of the commons is when overfishing happens because you can't really control who goes into the sea. And the people who go into the sea are incentivized to take out as much fish as they can. So the market failure is overfishing. If you overfish, the fish stocks decline and they will run out one year. And clearly this is a really bad situation where we'd have no fish anymore. Clearly the social optimum is when we would have some fish so that fish stocks kind of remain stable. That would be the best, I guess, or they slowly increase, but we don't want them to ever decline. That's a market failure. The immobility of labor. This is talking about how you find it difficult to change occupations. So say you want to become a doctor, it's like good luck. You're going to have to train for 10 years plus spend a lot of money and pass all your exams. Very difficult to become a doctor. It could also refer to geographical mobility. So you might not take up a job in London because it's the cost of living there is really high and you could be worse off. So that's a misallocation of resources because the skilled people, the people who could become really good doctors or who could do really well in their job in London, don't get there. So that's kind of some background on the immobility of labor. So A is the answer because if there's a change in the demand, like we're having at the moment with COVID, if people are buying more stuff online and they're avoiding buying things in person, then the demand for labor starts to change. It starts to change to be just online related employment. And that area could be employing a lot of people. But if you're working in person before, you might not have that many digital skills to apply to this new in-demand jobs. So even though there are online jobs available, you might not be able to be qualified to take them on. And so you might become long-term unemployed. And if there aren't any retraining programs, if it's difficult to acquire these digital skills, that the immobility of labor has made the switch to online living more difficult. That's a great question. I know lots of people struggle with this one. To work out an index number, the way I do it, and you might learn it different, but the way I do it is I just work a percentage change out. So we're told that 2013 is the base year. That means you should give the 2013 an index value of 100. And for me, I just compare everything else as a percentage change to that. So in 2016, let me see what value this should have. So right now we have 271, which is, I'm going to find out what percentage higher than 215. Got my handy calculator to work this out. Then times by 100. And I get 26.05% or something. Right, so then I need to add on 26% onto the 100. So the way you could do that is do 100 times 1.26. And if I do that, I get 126. That's my index number, and so the answer is C. Okay, this one's a difficult one. Let's try A. External costs have reduced the quality of life. External costs are your externalities. I don't have any information on that here. I mean, I guess you could assume that with more growth in the economy, with 6% growth, you have polluted, but I'm assuming I can't actually conclude that, so I'm not going with A. Real GDP per capita, great, we've got to work this one out. So real GDP, to calculate that, we need to take the nominal GDP, and then there's a few ways of doing this, but the way that I do it, I divide it by the CPI index, which has been divided by 100. That's how to work out real GDP. And unfortunately here, because we're not actually given any numbers, it makes it quite like an awkward question to work your way through. The way I would do it is I would just give this number a value of 106, this one a value of 104, just assume the year before was 100, and this would be 92. Great. So with the GDP being 106, the rate of inflation, this means that the CPI index here is now 104, so I want to divide that. I don't have a division thing. Divided by 104, which has been divided by 100, and I get a real GDP of Get a real GDP of 101.9. We need to work out per capita. So to do real GDP per capita, you take your real GDP, you divide it by your population, your size of your population. So the size of the population here is 101 in this made up situation. So I'm dividing that by 101, and I get something like 1.009, where the previous real GDP per capita would have been, before the 6% increase, so it would have been 100 GDP divided before the 1% population increase divided by 100 would have given me a real GDP of 1. So that means that the real GDP has increased by a little bit, so that's definitely wrong. The distribution of income has become more unequal. We need that Gini coefficient to increase, and that is not the case here. Standard of living has probably improved. Yeah, this one you can see because prices are increasing, but they're increasing slower than income. So people are earning actually a little bit more, even more than the cost of living has been increasing. So they can buy more goods and services, and that's what your standard of living is. It's really how many goods and services that you can buy. So that's the answer. Good question. Oh, here's another one. Okay, so for this one, I assume we need to work out the multiplier. We've been told the MPC. So I'm going to write everything that I've got. MPC is this. To work out the multiplier using the MPC, I do 1 divided by 1 minus MPC. So if you do 1 divided by 0.4, you get 2.5. That's the multiplier. And we're asked something else. We're not asked about the multiplier. So here's another equation that I think we can use. The multiplier is the change in national income. And then you want to divide that by the size of the injection. I'm hoping they've given us these values. Yeah, they said the injection is 19 billion, so this is 19. We don't know what the national income has changed, but we know that the multiplier is 2.5. So you can rearrange to find x. You do 2.5 times 19 in my calculator. And I get 47.5 billion. That's the answer. To measure unemployment, think of the labor force survey. And what we do is we look at the people who are seeking work and available to start work. This is an okay definition. Honestly, it's that you're seeking work in the past 4 weeks and you're available to start work in the next 2. That's what the labor force survey measures. That's the answer. Right, the movement of this economy from that equilibrium to that one has been caused by a shift of that long run AS. So I'm looking for more factors of production that didn't exist before, or I'm looking for like a higher productivity from them. So that could be because of more technology, more education, better health. I'm looking for things like this. Here we go. B is the answer. So here we've got a minimum wage that has raised the wages. Cool, that's going to cause that much quantity demanded because that's where your wage meets your demand curve. And at the same time, that's going to cause this much people supplying themselves to work in this industry. It's really motivated them to work because they can get paid a little bit more. So we have a problem because we have unemployment. Unemployment, remember, is defined as the people willing to work, the quantity supplied, and the ones that actually do work, the people who actually get employed are the ones who are demanded. So here we've created unemployment. The type of unemployment here is not because of a recession or a boom, it was because of a legislation. It's not frictional unemployment because people aren't between jobs here. This type of unemployment is actually called real wage unemployment, where you've raised the wage too high so that there's more supply than demand. And that's the answer. Right, if a bank makes a loan, let's imagine this. If a loan of £200,000 is given out to the customer, that means that the bank is going to lose 200,000 today. So in terms of the economic money supply, that is going to mean that the money supply in the economy is going to increase because there's £200,000 more. So we're looking for something like this. Right, the bank has an asset now because they know they're going to get paid interest payments every year. They're also going to get the principal paid back. So the bank, by giving out this 200,000 loan, knows that in the future they'll get back, say 300,000. And an asset, you have an asset when you know you get benefits back later. So the bank's assets have increased. And at the same time, probably the bank borrowed some money. Actually, that's usually happened. You borrow money between other banks to be able to get that loan in the first place. So their liabilities have probably increased too. So A is the answer with that one. Bond pricing is another favorite. So I'll write down what we have. We have the price of the bond originally is 100. The guaranteed return, which I call this a coupon, I'm just going to ignore that word, is 6. And this bond lasts for 35 years, paying this £6 return. After this time period, you get back the £100. Right, that's what it's told us here. The current yield is 5%. So if I were to define yield, that means how much an investor can expect. As a return on the bond, given it pays £6 per year and given its current price. So the return for the investor is kind of defined as how much money they get back, which is that coupon payment, that's £6. And is going to be defined as how much money they actually threw at this bond in the first place, at the price, the current price. It's a percentage, it's going to be multiplied by 100. So we're going to get 6 divided by P2 times by 100. And we know that this thing called the return is actually technically called the bond yield. So this currently is 5. So you need to rearrange this to get back the price of the bond. So trusty calculator. And we get the price of the bond of £120. So what did I do to rearrange that? I did 5 divided by 100 equals 6 over P2. I need to get P2 on the other side, so multiply both sides by P2. If you do that, the P2 will cancel out. And you're left with P2 times 5 over 100 equals 6. Get rid of that 5 over 100 thing. So P2 equals 6. You need to divide that by the 5 over 100. And then if you do that, you should get 120. That's the answer. Exciting. Right, a money market is, appropriately chose this background. It's where the banks borrow for short-term needs. So we are looking for something to do with borrowing. We're looking for anything short-term thing. That sounds good. Foreign currencies traded, no, that's your Forex market, your foreign exchange market. Shares, this is actually the capital market. Bonds, again, is your capital market. So I already know B is the answer. Just in case you were curious, the market where businesses obtain funds to finance long-term growth, that sounds like they're releasing bonds, which is something you do in a capital market. Tax rates, watch out for this one. A lot of people will not go through each of the steps to work out the tax due. Someone earning 40,000, don't jump to this category. Don't do 40,000 times 0.3, you'll get it wrong. Make sure to go through each of the brackets. So this person will pay 0%, so zero tax, on the first £10,000 that they earn, which is going to mean zero tax is due. On the next £20,000 that they earn, they're going to get tax 0.1, which gives them a tax bill of 2,000. For the amount above 30,000, they only have 10,000, so they're going to get taxed 10,000. So taxable income times the 0.3, giving them a tax bill of 3,000 in this category. And overall, the tax that they owe is therefore 5,000. That's the answer. Okay, national debt, for those that are curious, is about 2.4 trillion at the moment. Really, really big number. I think it's higher than our GDP. To calculate the national debt, you have to add up all the budget deficits, all the times when the government has spent more than they have. And then you have to add on the interest payments, which are really high. We spend like £40 billion on interest payments per year or something like that. So the national debt is the annual budget deficit plus, no, not this external, no, that bit's wrong. External trade deficit, it doesn't have anything to do with exports and imports. So that's what that means. So ignore that bit. They're just making it sound half good. So you pick it. The amount by which the budget deficit increases per year, that sounds to me that would calculate roughly the change in national debt, excluding interest payments. Well, actually, if the interest payments are in there, maybe change in national debt, which is not what they're asking for. Annual difference between their spending and tax receipts, that will measure the government budget deficit. So that is wrong too. And here, finally, you have the adding up. That's what it means with cumulative stock. You add up all the budget deficits, all the amount that they have borrowed every year, and you get the national debt. Oh, comparative advantage. Great. So we need. I usually create a separate table where got Brazil, USA. We're going to put the opportunity costs of motorbikes and cars. Right, to work this out, what I do is I say right now Brazil can make 10 motorbikes or 5 cars. So that means to make 1 motorbike, they are sacrificing 0.5 cars. And if you remember, opportunity cost is always what you sacrifice. So I'm going to write down in this table the thing that they have actually sacrificed, which is 0.5 cars. And that's the opportunity cost of Brazil to make a motorbike. It's really kind of different in that sense. You actually write down the car, not the motorbike. The opportunity cost of Brazil to make cars, that's easier to work out. All you do is the inverse. So you flip that fraction round. Before it will be a half, and now it's kind of 2 over 1, which gives you 2. So the inverse is 2 motorbikes. And then we repeat it for the USA. So the USA right now can make 6 motorbikes or 2 cars. So 1 motorbike costs 2 over 6 cars, which is 1/3 cars. which is 0.33 cars, and then flip that round to get 3 motorbikes as the opportunity cost for cars. So to see who has comparative advantage, it's the country that can produce things the cheapest. So to make a motorbike, who can make it cheaper? Comparing Brazil and the USA, and it looks like the USA wins. USA has comparative advantage in motorbikes. Wonder if that's an option. No. And Brazil has an opportunity, a lower opportunity cost in cars. So they have comparative advantage in cars, but they don't have it in motorbikes. We've just found out that's the USA. So the answer is B. That one's a cool question. Okay, higher HDI is better. This is a really developed country. This is among the most developed countries in the world. So remember, the HDI looks for things like education, health, and also life expectancy. So I'm looking for these to be really good. So immediately I can cancel out B and D. Low levels of illiteracy means generally low levels of education. And now we're between A and C. So, whoops, I have to add another one. And incomes. A is probably wrong. A country that has lots of dependency on the primary sector is probably going to have very volatile and low incomes as they specialize more in mining or agricultural products. Oh, I made a mistake. They're also going to have probably quite slow population growth to be able to educate, to be able to invest in the health of them. The answer is actually D. I misread that one. D, relatively low levels of illiteracy. This is good. This shows good education. So the answer is D. Consumer prices index. Right, classic question. Classic question. Again, if you want to work out inflation, you have to work out the percentage change in these over time. So this would be minus 2%. What is 103 minus 98 divided by 98 times by 100? That is 5.1% inflation. Then keep going. 105 minus 103 divided by 103 times by 100. 1.94% inflation. I'm just working out the percentage changes. This is 0.95% inflation. Percentage changes, you probably don't have to work all these out, but I don't know, I think it will make things easier. 1.9. And then finally the last one, times by 100, 2.88%. Great, so now that I've got this, hopefully things will be easier. Countries suffered disinflation in year 5, right? So in year 5, oh, they're matching up these numbers. Disinflation, I'm looking for a reduction in the rate of inflation. So in year 5, the inflation increased by 0.95, which was less than the time before. So that actually looks like the answer. Inflation rate was highest in year 7. That's wrong. That's wrong. It was 2.8% inflation. But there was another time when we had 5.1. So that's not the answer. The only time country suffered deflation was in year 2. So yeah, it fell. Did it fall any other time? Oh, it did, and I didn't write it down. 2 divided by 106 times by 100. It's good to double check these. Look at the things that you can miss out. Yes, that should be a minus figure. So that's not the only time. Real incomes fell. I can't say this from this table because all I know is inflation, and incomes also depend. Real incomes depend on your income. So we are left with A. So this short run A has to shift, what's it shifted? Right. So it's shifted to the right. This thing shifts to the right because of lower average costs of production. So I'm looking for something like that. And hey, look, that's the answer, D. Lower world commodity prices. If your raw material, so your coffee grains, your coffee beans, your rice, well, that's cheaper. Any food farm is going to face lower cost of production. Also, oil will be included in that, metals, so that will reduce costs. Oh, xmlt question, these are great. Market failure occurs at the free market equilibrium. Okay, for those of you who don't know, the free market equilibrium is always where the selfish firms meet the selfish consumers. So we're looking for the intersection of that one with that one, which occurs at that equilibrium point. So this is the free market equilibrium. Right, so how do I know there's market failure here? Because at Q1 and P1, the social costs are lower than the social benefit. I'll show you what I mean. So the social costs, should have written them in red maybe, are there at Q1. If you go up, that's where it meets your social cost line. That's where your social costs are. And your social benefit, going to go up from Q1, see where it meets the social benefit curve, which is there. So there's a difference between them. And what that means is we could have been better off by consuming more of this product because it's having a net welfare improvement if we were to consume those units. So for allocative efficiency, so to maximize welfare, we should consume all the units where it's still true that the benefits are higher than the costs. So we should have consumed all of these units because for all of these units, the benefits are here, but the costs are there. So we could have gained all the welfare between the benefits and the costs, which is going to be this yellow triangle. That's why I know that there's a market failure. We're not maximizing welfare. So let's go with the options. Deadweight loss, the deadweight loss was this bit here, which is XYZ, which is not that one. Consumer surplus is reduced by this. Consumer surplus would be that area at the free market. And if we had consumed that P2 and Q2, we would have had this consumer surplus, so we would have gained that, which is not what they say. P1 minus P3, that's the answer. Right, so right now we have an equilibrium of this. We want to get to an equilibrium of that. And one way we could do this is through a subsidy. So a subsidy of the distance between that and that, for those of you that are unaware, will actually cause your supply curve, your MPC curve, to giving this to the companies themselves, it will reduce their average variable costs of production by the subsidy. And so this is going to be your MPC with the subsidy added to it. And so we will have a new supply curve, which is there. And so you'll have your firms producing down, your consumers consuming on the demand curve. So that's going to work. We know we achieve the social optimum because, as I've said, you've gained all those benefits, all those net benefits. There's no more where that's true. So you've maximized your welfare. Okay, PED. Cool question. So to work out PED, Remember, it's always quantity on the top. Always, always, always. Percentage change in price at the bottom. And then we are told that this equals minus 1.2. And we're told that the price falls by 10%. Right, so I'm going to rearrange this first. So I need to work out the percentage change in quantity demanded. And I can do that by rearranging this like this. So percentage change in quantity demanded is going to be minus 1.2 of the PED times as a minus 10% change in price, which gives you a positive number if you multiply two negatives together. If not, just check on your calculator and you get plus 12%. So D is the answer. I have the solutions pasted here in the link. So if you find the link below, you'll be able to access this document. But other than that, it was a hope you found this really useful and also really interesting. And bye.